Thank you. Also, thank you for the nice food. We all enjoyed it, I think, and don't worry, we won't be too technical in this presentation. So even for the lunch might have been heavy. Don't worry about that. We got you covered. Yeah, I think we already discussed this during lunch. So before we had crypto, now we have legal tech AI. So we got almost all of the technical buzzwords here at the Exoscale acceler8. So thank you for listening to our presentation. We are Legartis, so first of all, we also are going to have our sales pitch when Toby is going to go more into detail of what kind of processes we have and the challenges. And then in the final round, we will talk to you about how we do this on Exoscale and also why we choose Exoscale for our services. So, yeah. Toby and me, we already got an introduction, so here I'm already starting with my sales pitch. I actually am only with Legartis starting this year. So why did I choose Legartis personally? I have a history with startups. I was a consultant, so naturally I got in contact with lots of contracts, not because I wanted to, but because I have to. And then when I went to Zurich, I was looking for new startups which were interesting to me. And here I found Legartis. So Legartis is in the contract space. Legartis is basically the contract review software to review your contracts. And for that we use AI, which we train with our platform. So about Legartis, Legartis was found 2017 in Zurich. We also have our main office in Zurich near the Hartplatz. Right now we have about 35 employees. Of course, here the interesting part about a legal tech startup is we have developers and we have legal people in the same startup. So two worlds come together to start a venture. Yeah, what are the unique selling points of Legartis? So Legartis, as mentioned before, we review contracts. So how do we do it? We have an in-house training solution, an in-house training platform. Toby will later tell you more about this in detail. But this basically means that we get customer contracts, we all get contracts from development partners, and we use these contracts in-house with our in-house training solution to train the AI. And that means for our customers that they can use our tool in our platform from day one. So we don't train the AI for each customer individually, but we train it for our platform for all the contract types that we currently cover. For example, that right now is DPA, this is NDA, and we also have an agnostic contract checker, which covers basically 20% of the most used contract clauses in all different contract types. As of right now, we train two languages, English and German. The reason is that we are currently focusing on the DACH region, but this, of course, can change in the future. Also, since we're talking about lawyers, it's very important to not only have a platform with APIs, but also to have already a front end. We'll come back to it later, but what we're currently mostly selling is our integrated Word add-in. So here, the lawyer can instantly use our software without like a long onboarding process. They simply use the environment they know already, which is Word often in the lawyer space. So they open the contract, they start Legartis, and similar to like what you could imagine with a grammar check. Legartis scans your contract. We detect like clauses which are in the contract because, of course, we trained AI to detect that. And then Legartis will tell you, okay, this clause, it does not belong to your company guideline. You should not have this. This is basically what we do. So just also for those who are not really familiar with the contract lifecycle, there's a big lifecycle involved contracts, of course, so you can start with drafting a contract, then there's also like the pre-signing phase, which is negotiation, review, approval. This basically is the most part of the pre-signing process, and this is also where Legartis focuses on. Of course, there's also our processes involved in the big contract lifecycle chain, which is like signature, of course. Then after the signature, you have like post-signing processes, which are like tracking, renewal, but that is not our core competence. Having said that, I pass on to Toby.
Thanks, Gordian. So, hello everyone, also from my side. So, I'm digging a bit into the two processes, the two main processes we have at Legartis. So on one hand, we have the, let's say, the customer process, and on the other hand is how we train our AI to improve the classifier. So how does every Legartis story start? It basically starts with, hey, I'm calling my lawyer, and afterwards a lawyer, a legal or a paralegal will open Microsoft Word, and what we are doing, we have something called a Word add-in. So on the very right side, you can see our Word add-in, which you basically open in Microsoft Word directly, so you can manage and edit your contract at the same time while you are analyzing it. This is how it starts. Next step. So we have a whole pipeline of tasks we are executing. First, uploading the document, what we already explained. Text segmentation, language detection, then visualizing the results and checking customer rules. So each customer can basically define his own rules, what he wants to see, what is relevant, and so on. Yeah, here we start with the first task. So text segmentation, which is our machine learning experts will probably say this is one of the most important tasks, because if you do a mistake here, then it's really hard to train a classifier, right? So we have two sentences here. Es wird eine Laufzeit über 2 Jahre vereinbart. Gerichtsstand ist Zurich. You want to split those two sentences into two segments. We call them segments. Then second use case is a bit more difficult. So here you have also currencies in there. And the difficulty here is that if you see a point on the on the right side of the currency, then you don't want to split this into two sentences, right? So you still have two parts here. Es wird eine Laufzeit über 2 Jahre vereinbart, and the second segment is basically eine Kostenbeteiligung über 30.000 Franken. So this is the main difficulty. And as I said, if you do some mistakes here, then on one hand, the annotation process, our machine teachers, which are annotating basically the classifier, will basically annotate something which is not really relevant. And on the other hand, yeah, for the customer, it's also not really meaningful because there are two different sentences messed up together. In the second stage, what we are doing is language detection. So that's a pretty straightforward task. On the very top, you see a German sentence. On the bottom, you see an English sentence. This gets or can be a bit more complicated if you have mixed sentences or English words in German sentences or something like that. So why are we doing that? We have two classifiers, as Gordian mentioned. We have one in German and one in English, and then for a couple of contract types. So it's important to know the language before we can load the right classifier. Afterwards, here's the real prediction part. So we have something called a provision classification or a sentence classification. We want to know what is Gerichtsstand ist Zurich. This is probably what every engineer can predict. It's Gerichtsstand for sure, but it gets a bit more complicated on the bottom. This agreement is drafted in Russian and English languages, anwendbares Recht. So this is what afterwards our machine learning classifier is doing, so the actual work. Yeah, so afterwards what happens is the customer is still in his Word add-in, and he wants to see the result on the right side. So he doesn't care about language classification and text segmentation. That's really technical stuff. But what he wants to do is he wants to basically say, Gerichtsstand ist Zurich. He wants to be able to say, this is not really relevant to me, because Gerichtsstand is probably already part of every contract. But what the customer doesn't want to see in a contract is, wird der Vertrag von einer Partei nicht erfüllt, so hat sich die Gegenpartei eine Konventionalstrafe von 100.000 Franken zu bezahlen. This is Konventionalstrafe, Vertragsstrafe. So a lot of companies will say, hey, this must never, never, never happen in our contract. And that's why we basically do pre-signing, because you can still make changes before you sign the contract, right? So the company will say, hey, please change the contract. And the customer will directly see that on the right side in our add-in. So this is the analytics part. You see how many open tasks you have, how many completed tasks you have. You can also see one clause is unacceptable. That's, for example, Konventionalstrafe. You can see 9 clauses are missing. So you want to have 9 sentences in there which are missing in the contract. And then you also have a lot of many other features. We're not going into them too much. But if you're interested in, please contact us, and then we can for sure help you. Yeah, then the second workflow. This is now more about the classification part to improve the classifier itself. So we have something called machine teachers at Legartis. What are machine teachers doing? So they are lawyers or ongoing lawyers annotating sentences and segments. They are really saying, hey, that's this clause, that's this clause, that's this clause. Basically, it's about collecting train data. Finding relevant segments, then we do evaluations for sure, and we use that information to improve our classifier afterwards. So here, just a couple of challenges. Deduplication and garbage removal of sentences. You probably want to exclude all sentences shorter than, let's say, 5 characters, because it's not really meaningful. It can't be, right? Then deduplication, you don't want machine teachers to annotate sentences multiple times. If you already annotated them, it should be clear that's this sentence and that's this sentence here. So you can save a lot of time if you do a good job here. Then we have evaluation of machine teachers and their annotations. So I already explained what a machine teacher is. It's basically like a collaborator, a friend, like teaching the machine or teaching our classifiers. And the tricky part here is you want to basically, we're doing something called an inter-annotator agreement. What does that mean? That means we are comparing the annotations of one machine teachers to the annotations of another machine teachers. And you will be, like, it's really funny what you can see in terms of differences, because sometimes it's even unclear for machine teachers, right? Not only for the machine. What you also can do is you can, for example, compare the annotations of one machine teachers with a next annotation iteration round. So a machine teacher is sometimes doing a second round, a third round, and then you can basically compare the first round with the second round. And it's funny, but it's not always the same that is being annotated. So yeah, those are just a couple of interesting facts. Then auto-creating new annotation projects based on previous classifier results. What does that mean? That means after a machine teacher annotated a project, we are immediately training the classifier again to see how is this changing the classifier quality itself. So very important, the numbers, you always need to have the measurements, you need to have the metrics, and for that, this is an ongoing process. So first, creating annotations, evaluating annotations, and afterwards annotating the annotations again. Yeah, the release process at the very end is also an interesting fact. You don't want to release a classifier directly into production, because it's sometimes really hard to annotate the sentences. And what we are doing at the very end is a legal engineer, that's basically a lawyer looking onto the classifier. What is it predicting? Is it really correct? For sure, we also have automated tests doing that, but like you want to have a human at the end hitting the button that this should go into production, right? Because it's really an important part or piece of our software. Yeah, just a couple more classifier facts. Like multi-label classification, it's transformer models. So we are using now deep learning models, not only SKS. So a really complex classifier, which is not only 4 megabytes big, it's more like 400 megabytes in terms of size. So a lot of complexity in there. And this is one, I would say, major reason why we also changed to Exoscale, because they are offering GPUs deployed in a Kubernetes pod, which is, yeah, pretty cool. You can do that within a couple of minutes to deploy something like this. Yeah, so now I pass back to Gordian. He will tell something about the whole infrastructure part, how we deploy it, how does it work together with Exoscale.
All right, thank you, Toby. Yeah, of course, coming with all these processes, it comes, of course, with lots of technical and infrastructure requirements, but not only technical, but also business requirements. So, for example, I guess it's very obvious that contracts are like very sensitive data. I think other data, some companies might just think, okay, I just need to comply to GDPR or some local regulations. Let me just choose, for example, Azure in the Zurich region. Because when I comply, everything is fine. But I mean, for our customers, this is not really the case. So they are really sensitive about their data. I mean, even just a simple NDA could contain very valuable business information. If it gets out, it gets stolen. Someone could know business parties and the deal size maybe, and that's definitely something that is very sensitive. So one major requirement is for our software to run on a Swiss provider that we trust. Another thing is that we have a microservice architecture, we have lots of services, a sort of inter-service communication, and to have that standardized, we are using Kubernetes, so our provider should offer us something with Kubernetes. Our provider should support infrastructure as code, because this is a wow. We made an infrastructure, and our dev team, we want to have everything, even our configuration, stored as code. We want to be able to audit it, have a history, all these things you get with infrastructure as code. So of course this goes also for our infrastructure provider. We have to support that. Very important, we need to have GPUs, simply because our models require GPUs for training, also for inference. And of course, since we are running on Kubernetes, the Kubernetes cluster that is managed should be able to support these GPUs. Not every provider offers this. Then the next thing, we are not really, I think the Ivan guys explained this really nicely before, so scaling your own logic is one thing. You can scale it horizontally very easily, but scaling data access or data you store and want to access, that's a whole different story to scale it on your own. So here we were looking for something which is like a DBars. So since we're using Kafka for event-driven architecture, we need to have a DBars, and the same thing goes for Postgre and Redis, which we're also leveraging, something we do not want to scale on our own. So with that in mind, we found Exoscale. So this is a very high-level infrastructure architecture of Legartis. So on the left side, you have our front ends. For example, all of them are Angular applications, so they are not running on the servers. I mean, the files are just getting served. But basically here we have our Word add-in, which is an Angular application. We have our Angular dashboards where customers can set their company guidelines, onboard their employees, and of course we have our own internal back office as a front end. So, and of course these front ends, they communicate with our platform, which is our Legatus. So there's the training platform, the training APIs, and of course the customer-facing APIs that support the processes that Toby explained. So here we're starting on the right side, we are coming into the Geneva region. So having said before, we want to have everything in Switzerland for our DACH region customers. And that of course includes the load balance on the left side. So all the requests first go into the network load balancer from Exoscale. And then we are already coming to the SKS clusters. So SKS, I will come back to it in detail in the next slide, but it's basically the scalable Kubernetes service from Exoscale. So here we're running two clusters. One is our infrastructure cluster. So nowadays, even if you have Kubernetes, you need a lot of infrastructure tools to just be able to run your own application. So there comes secrets management, monitoring, what else do we have? Authentication, all these kind of services. You also need to be able to run them, scale them, and they should be operational. So we also want to use Kubernetes for that, and we are doing that. And then we have a separate cluster which is running with GPUs and CPUs, which is running the actual Legatus stack. And of course, they communicate with each other. And then on the right side, we have DBars, database as a service, and storage. So this is all the things we don't want to do on our own. So this is why I have it separated. So this goes for S3, Exoscale S3, then we have Postgre, Redis, Kafka. I think we almost cover all the services that are currently used. I think the only thing is OpenSearch that we do not use right now. Yeah, so let's see. We are not going to explain that. Let's see why we chose the SKS on Exoscale. So one thing we don't want to do is basically we don't want to manage the hardware. And this picture I stole from the Exoscale documentation basically highlights this very nicely, what they actually control and what we have control over. And what we basically want to be able to do is we want to have lots of control over our Kubernetes architecture. Like we want to be able to have like our own networking policies within Kubernetes. We want to be able to roll out like device plugins like GPU. We maybe want to later connect to different clusters with like some Kubernetes services. So that basically means you need to have lots of control and access. But at the same time, what we do not want to do is we do not want to maintain hardware. We do not want to have to be able to manage these operating system upgrades. All of that, that's something we do not want to do, and that's something that Exoscale manages for us. And then coming to GPUs. So let's say you start with a SKS cluster on Exoscale. So you simply, what you need basically, so an Exoscale, it's basically the hardware scaled having node pools. So a node pool is something basically that groups like logically instances of the same hardware. So like you have a node pool of a GPU type and you have a node pool with like a CPU medium size. So you have like maybe 8 vCores, and basically this node pool then scales these instances horizontally. So if you want to have like a cluster of GPUs, you probably need like a second node pool, because usually you want to start with CPUs because they're simply cheaper and not all of your load needs actually GPUs. But having done that, so let's say, okay, we already have like our node pool of GPUs, maybe you're starting with 2 or 3. It's very easy to set up. And the next thing is, of course, to make Kubernetes detect these things so that your pods or deployments can actually use this GPU. And that's actually very easy. So NVIDIA, for example, has an official device plugin driver for Kubernetes. So basically, you literally just need to install this device driver, and then that takes around like maybe 10, 15 minutes to set this up. Then you're already able to add like GPUs to your pods. Because what this device driver basically do is that it makes Kubernetes know about a GPU as a resource. Because by default, Kubernetes only knows about maybe CPUs and RAM. These are like the things that probably every cluster has, but it doesn't know how it should assign like, or like how it should divide like all these GPU resources. And then I think at the script at the bottom line, you basically just need to, at the pod level, you basically just need to tell, okay, this pod needs like GPU resources, and then depending on the device drivers, there are like multiple device drivers available. Looks a little bit different, but basically for the NVIDIA one, you will basically increment like an integer. So here, for example, it's set to 1, so it means this pod has full access to 1 GPU resource. And this is also kind of a limitation, because this default driver from NVIDIA, it doesn't allow like multiple pods to access 1 GPU. It's basically always 1 pod per GPU, and that's might be something that you're okay with, might be something you're not okay with. For right now, this covers our use cases, because we have a few GPUs, which makes our pods still highly available. But if you have a higher load than us, you might be looking for a different driver, which might be a little bit more complex to set up. But they are out there. All right, coming to DBars. I think I don't need to talk too long about this, because I think since Ivan was before us, we already explained why we should not host our data on our own, because basically the gist of it is scaling data is way harder than scaling anything else. At least that's what I always noticed in the past, and this was always the main trouble. Having said it, it's one thing to just set up like a default setup. I mean, yeah, like setting up like a deployment on Kubernetes with Postgre takes maybe like 10 minutes, but it's not highly available, it's not encrypted, it's not secure, it maybe not scaled by default, so that actually takes your time, and that's actually really a pain to support that in the long term. And also this is not the thing that we do and we don't need to have like these really customized settings, so database as a service is basically a perfect use case for us. So here we use Postgre, we use Kafka, we use Redis. Did I forget something? No, I think that's it. And also one good thing, I think someone asked us in the presentation before, but basically latency, of course, is like an interesting topic, and this is also why we choose Exoscale and Ivan, because it's also running on Geneva on the same region. So of course we were also looking at other DBars providers and could have also used maybe Ivan without Exoscale, but in the end we saw that okay, this is very nice, it's already integrated. You don't have to do anything, you can use the APIs from Exoscale to set up provision Ivan. You can also of course use then Terraform. You have everything in one hand, and I can say it just works. And that's all we want to hear from our DBars provider. There's just one thing you might need to know, so how is this secured? I mean, by default, it looks like all these services are encrypting the data at rest. It's also encrypted in transit, which is something, of course, it's also like a requirement we had, but also the connection between our cluster and these Ivan instances basically works over an internet connection, so Exoscale provides a firewall for this. And the interesting question we ask ourselves, okay, how do we then connect our scaling clusters? How do we actually set up these IPs in these DBars services? Because, okay, let's say we have a higher load, suddenly we are scaling our services, we have more nodes, we have more IPs. How do I get into this firewall? Because, of course, we still want to access these DBars providers. And there's a pretty nice solution. I think there's like a snippet that Exoscale actually provides on GitHub. So we used that. You can basically scans the Kubernetes API for nodes. When there's a new node detected, it reads the API. When it goes against the Exoscale API to read out the database services in which IPs are currently whitelisted, detects the difference. And if there's a difference, of course, then it updates it. So all in all, that is solved. Yeah, that's it for DBars services. I mean, right now we are still using the basic Kafka features, but we also noticed that there's like a Kafka Connect, Kafka REST, and the schema registry interested. So that's something we are personally looking for. At some point, we don't have experience with that yet, the current cluster. And also, we are very happy that block storage is coming at some point, because that is the final piece to the puzzle of not having to manage data. So right now, we still, this is the last part we still have to manage on our own. So, thank you for your interest in Legartis and listening to our presentation.
Thank you very much. It was a very interesting presentation. It's a very, very cool business model. So maybe the audience has questions for the business model as well, for the technique as you use it. So please ask some question. Maybe from Avon, maybe you guys have question, or say thank you for using Avon.
I want to understand something, the way you do the tokenization and everything. Do you use stuff that has been done in the GPT-3 project or GPT-2 or something like that, or these kind of models that right now can be used or trained over to be like more expert system, that the way you are doing? So perhaps can you like explain where you started from the beginning? I would like, is the way that appears to me when I look to the presentation, is like you have done the whole system. So perhaps can you explain us like what you have found, like something special, of why not using a uniform model first and then make it expert over creating a model from, like it seems from scratch. So that's clear? Or? It's a tough one.
I'm not 100% sure if I got the whole question. So you're basically saying, why did we do it on our own? Or?
Yeah, I think I've used GPT-3, and you can just use the same techniques, and you can buy the model or buy the API, and then you can do what you're doing. But you start from something that really understands the text, and in multiple languages. So it's very good for English. It's less good for other languages. But right now, it really understand the text very well, and then you can have some specifics over it. For example, rephrase or understand the phrase or propose some correction to some sentences. And then you can make, for example, you can use GPT-3, then you go to all the customers, like legal contracts that exist, and then you just learn over all the way that this company just phrase all the contracts and everything, and then you can propose stuff over this. So I want to understand, like, is this your target at the end to do something like this? Like, because that's really expensive. Like, it's not one GPU. It would be like, you know how much it is.
Yeah. So in general, about the models itself, I would say law is not always law, right? And language is not always language. But for sure, we are using existing classifiers and models, things like that. It's not like we're building everything from scratch. So we started probably exactly as you mentioned. But the tricky part is also if you have a model like BERT or whatever, then you still need to do some kind of transfer learning in terms of very special sentences, especially sentences that are hard to understand even for lawyers, right? And as we mentioned, like, law is not always law. So in Switzerland, it's possible that you have different provisions and different classification than in the US, for example, something like that. For sure, we're not tackling US at the moment, but yeah, that's why we had to basically do a transfer learning on, as you mentioned, existing database, existing classifier models. Yeah, but it's a really good question. Yeah.
Thank you. So, other questions? Antoine, sorry, wrong direction.
Just on your diagram, you have the pieces that are running in your infrastructure cluster. What's the DBars filter? Is that that's the snippet for?
I skipped it. It's basically in the infrastructure cluster. It's a Kubernetes deployment, and that deployment basically scans the Kubernetes nodes.
Ah, that's the script you talked about. Cool.
Yeah.
Thanks.
Yeah.
Thanks, Antoine. Maybe I have, as usually, also a question. It's more from a business side. So as most of you, the customer you talk with are from legal.
Mm-hmm.
So, and how aware is the topic, or how much is the need of having a company which are fully compliant to the GDPR law, which means, is this a topic from your customer? Are they choosing Legartis because you have no relations to the USA, or is this never a question from your customers?
This depends. So GDPR is, of course, for some, especially German customers, it is a topic. Yes, that might be a reason to also choose us. But it's not only GDPR, it's also about trust. And that said, I mean, even with Azure, we would be able to comply to GDPR maybe. Mm-hmm. We could choose the correct data center. Mm-hmm. But they still don't trust the Cloud Act, for example. And they definitely are looking at where we host and where we store and how we encrypt our data. Yeah. It's definitely some customers look at it. And yeah, I mean, different customers have different perspectives. So basically, like an enterprise with like a sales department, which is just checking NDAs, that can be a customer of us. They might not be that interested in that, but for example, legal counsel, they are always thinking about liability, and lawyers always think about liabilities. And when they think, okay, it's not even our contracts, it's contracts of our clients, you better make sure these are stored in a safe way, because then we are also getting hit from that.
Cool, thanks a lot. So.